In this video, we're going to look at the mtan formula again. And as you can see, it says mtan equals what? And I have f of x equals 1 over x plus 2 at the point negative 1, 1. Okay, so first off, we're going to write that mtan formula with the limit as x approaches a of f of x minus f of a all over x minus a. Okay, now what's going to happen is that I'm going to plug in my function, which is the 1 over x plus 2, and this a and f of a are these numbers. So a is the x value, f of a is the y value. So when I go up to this formula and plug in, I'm going to get the limit as x approaches negative 1, right? Because that's a. And I'm going to have 1 over x plus 2 minus 1 over x minus a negative 1. So that'd be x plus 1. Okay, so just stopping for a second, making sure you are following along. I'm plugging in my function. I'm plugging in the y value. I'm plugging in the x value, and now I have all x's and numbers. Okay, if I plug in negative 1 right now, what you're going to get is 0 over 0. Okay, so we're going to do some algebra. Whenever I have a fraction and a fraction, we want to make a common denominator. So I'm going to go ahead and multiply by x plus 2 and x plus 2. Okay, all right, so let's see what I've got. I've got the limit as x approaches negative 1 of 1 over x plus 2 minus x plus 2 over x plus 2. And that all is going to be divided by x plus 1. So this guy down here, divided by x plus 1. Okay, when I distribute that negative, so now I'm going to have 1 minus x minus 2. So that's actually going to turn into, let's see if I can go ahead and fix that up. That's going to be negative 1 minus x all over x plus 2. 1 minus 2 is negative 1 minus x. Okay, now divided by x plus 1 means times 1 over x plus 1. Okay, and I still have my limit out front. All right, now I'm going to factor out that negative 1. Okay, so now that original denominator gets crossed off. Now, once I cross off my original denominator, so when I say original denominator, I mean back up here. Once that gets crossed off, I should now be able to plug in negative 1. So let's see what happens. I get a negative 1 times 1, which is a negative 1. I get a negative 1 plus 2, which is a positive 1. So I get negative 1. All right, so what I found out is for my function, 1 over x plus 2 at the point negative 1, 1, if I were to graph that, I have an instantaneous slope of negative 1. All right, so that's my answer. Now, for some of the problems, they also ask you to find the equation of a tangent line to this curve at this point. So that sounds like a lot of work, but it's actually pretty easy. If they ask us to follow up and do a tangent line, all you need to do is use your point, y1, x1, or your point, if you want to, you could write it as a and f of a, or you could write it as a and b. So I'm saying the y value that they gave me. So this x value and y value, the x value is negative 1. My y value is 1. Okay. And then the last thing I need to do is plug in the slope that I just calculated, and that's a negative 1 as well. Sorry, this example has lots of negative 1s floating around. All right, so let's see what I've got. So when I clean this up, I'm going to get the equation of the tangent line to that curve at this point is y equals negative x. Awesome. Now, since you guys all have access to the internet and Desmos, what you could do is you could actually graph this guy and graph y equals 1 over x plus 2, our original function. And what you should see is that it's going to, they're going to touch at the point -1, 1. So it should be a pretty cool graph. So check using Desmos and see what happens. All right, cool. There's our second video with the mtan formula.